number 14, we want to find the area of the region bounded by the graph of f of x equals sine x. And it says on the x-axis on the interval negative 2 pi over 3 to pi over 3. So we are looking at the integral from negative 2 pi over 3 to pi over 3 of sine x dx. Now we're going to do the integral, but again, it's asking for the area. So let me just kind of talk about the sine curve. Sine starts at the origin and goes up from left to right. Going to the left, it goes down. So I want to say negative pi. We might be looking at 2 pi over 3. Yep. So we're looking at somewhere over here. We'll be looking at this area, which will be negative, and then pi over 3, we'll be looking at this area. So again, we'll have a negative and a positive, but we'll have to multiply the negative of this side. And so we'll split this integral so that we can get area, change it to positive, and then get this area. So what we really want to do is we want to do integral of negative 2 pi over 3 up to 0 of sine x dx. And 0 stops where this graph goes positive, and then we'll do plus integral from 0 to pi over 3 of sine x dx. All right, derivative of negative, it would be negative cosine would give us sine. So going backwards, the integral of positive sine is going to give us a negative cosine. So we'll have a negative cosine of x evaluated from negative 2 pi over 3 to 0 plus integral from 0 to pi over 3 of negative cosine. All right, so we're going to be doing over here negative cosine of negative 2 pi over 3 minus negative cosine of 0, and then plus negative cosine of 0 minus negative, it should be pi over 3, sorry, upper limit first, minus cosine of 0. And this side we will multiply by negative to make it positive. That'll give us a positive area, positive area. All right, so let me talk about the trig or the unit circle so you can see where these values are coming from. Just as a reminder, homework folder, cheat sheets, handouts. We want trig cheat sheet. And we're going to be looking at the unit circle. All right, so cosine is the x coordinate. So when we're looking at cosine of 0, here is the angle 0. We're looking at the ordered pair, which is kind of hard to see here still. Let me see how much I can zoom in and still be able to see this. All right, so the ordered pair 1, 0, the x coordinate is 1. Now when we're going backwards, negative 2 pi over 3, pi over 3, 2 pi over 3 is here. But when we go backwards, it's going to be just the mirror image of that. So this would be pi over 3. This 4 power 3 will be a negative 2 power 3. The x-coordinate is a negative 1/2. So that's what we're getting when we plug in. We'll get a negative 1/2 here. So minus a negative is going to be a positive 1/2. Minus a negative, positive 1. So it'll be plus 1. That's what we get for the first part. And then on this part, power 3. Power 3 is this angle. The x-coordinate is 1/2. So we're getting a negative, because of that, 1/2. And then minus a negative, which becomes plus a 1. All right, so here we're going to get a positive 1/2. Over here, we are going to get 1.5. I do believe we're supposed to turn that negative to get the positive area. But if I do, that's going to give me a negative area. We don't want a negative area. So let me see if I didn't put the negative here. If we got a 1/2, 1.5 plus a 1/2, that gives us 2. Total area being 2. Maybe I just kind of got overzealous here. I do know when you do area, we don't want net area, we want the total, so it should be positive all the time. So I think it's the splitting of the interval that kind of helps us see this area and then this area, instead of subtracting this lower limit. Oh, what it was is I did this backwards. That's why it didn't come out. I was supposed to put the upper limit first. Should have been the one here, and then that would have changed the area. The bigger value would have been negative, and that would have changed it. So got to be careful there. I switched the limits. That's why the negative sign didn't take effect.